Okay, so basically in previous lecture what we have discussed about? We have discussed about introduction of plastic mold technology and the plastic material and its types, right? Okay, and the shrinkage value by the scale body, which is very important for the for fitment of the component, depending upon the geometry of the component, which feature is critical, which right, which face or the dimension is critical. Depending upon the dimension, we have to provide the shrinkage value by the scale body, right? Okay, and we have seen about types of shrinkage. What we types of shrinkage we have seen? Symmetric
Asymmetric.
and asymmetric, right? So you know about the importance of both. Okay,
Yes.
important 7 points today we will cover. Okay, and the core and cavity introduction we have discussed in previous lecture. What is the core and what is the cavity? Tell me what is the core and what is the cavity?
Male part will be the core, female part will be the cavity.
Yes, right. Okay. Okay, and the mold base, and we have discussed about its few materials, right? That what material we can use for the top plate, bottom plate, right, and the core and cavity plate. So we have discussed about that, right? Okay, so first of all, if I'm talking about the injection molding machine, or if we are learning about the mold technology, so we should have knowledge about the injection mold machine, right or wrong? Okay, so there is a data of injection molding machine which which a design engineer required to design the mold, right? Okay, so first of all, tonnage. Okay, as I told you, what is the meaning of tonnage? Nothing but it is the clamping force, clamping maximum clamping force, which is you can say that, which is provided by the injection molding machine during the operation, right? Okay. Okay, so here you can see that this is the injection molding machine, right? Okay, here, so basically if I'm talking about the injection molding machine, so basically injection molding machine is depending upon the availability, that what injection molding machine available to the customer. Is it clear? For example, customer has 30-ton machine, a customer has 50-ton machine, customer has 80-ton machine. So depending upon that, we have to verify that 30-ton, 50-ton or the 80-ton machine is suitable for our component or not. Okay. Okay, short capacity. What is the meaning of short capacity? Tell me. I'm talking about short capacity of injection molding machine. Okay, means how much material we can feed or we can fill into the impression during the one shot. It is known as short capacity, right? Okay, see here, what is happening here? This is the screw, right? And how much short it can be provided to the impression. The impression means this portion, right?
Cavity, yeah.
Right. Okay, so this is known as short capacity. Now if I'm talking about the short capacity, for example, I have a PP material, है ना, and we have a ABS material. So for the both material, short capacity can be different.
Yes, sir.
How? How it can be different? Tell me.
Depends on density.
Depends upon density, right? So I think in previous lecture we have discussed about it, right? Okay, so depending upon the density of the material, so short capacity can be different for the materials, right? Okay, now it should be more than component mass, right? Component mass in which will be in gram. Is it clear? And the tie bar distance. What is the meaning of tie bar? I'm talking about the bar. Okay, basically if I'm talking about the injection molding machine, the injection molding machine, injection mold, like the injection mold will be come from here, right? Hanging by the eye bolting, right? And it will be come from here. So basically we have to place into this area, right or wrong? So basically we should have knowledge about the what is the distance between the tie bar. One is the horizontal and second one is the vertical, right? So basically if we know about the tie bar distance, so basically we can decide the maximum length or width of the mold, right? Maximum length or the width. Is it clear?
Okay, got it.
Okay.
Yes, sir.
And the maximum and the minimum opening of machine platen. What is the meaning of this? Maximum or minimum. For example, this is the machine here, and here you can see that this is the moving platen. What is this? This is the moving platen where your, you can say that where your moving part or the moving part of the mold will be clamped, right? And here this is the fixed platen where your cavity portion or the top plate will be clamped, right? Is it clear?
Yes.
So basically, so we should have knowledge about the maximum and the minimum opening of platen. Okay. So beside of this, from the machine catalog, we get the information about the what is the mold minimum height and the mold maximum height. So what we can take, right? So there is no requirement for this point. Is it clear? Is it clear? Acha,
Yes.
I will add one more point, which is the ejection stroke of the injection molding machine. Ejection stroke. Now tell me what is the meaning of ejection stroke?
Taking out of the part.
Yes, bilkul. So basically you can say that depending upon the ejection stroke, your component height should be less than this ejection stroke, right? That's why you can say that you can eject the component in a proper way from the mold. Right, like this. For example, this is the mold here. You can see that this is the ejection stroke. See here, which is provided by the molding machine. See, right, like this. So basically, if I'm talking about this distance, see here, if I'm talking this distance, which is the component height, so component height should be less than this stroke, right?
Yes.
Okay, understood this point? Okay, have you
Yes. Yes.
have you take a notebook or the pen? For example, if I'm explaining
Yeah, we
very
are having the notes.
yes, yeah. So if I'm explaining very important points about the about the mold design or the points, right? So you have to note that, right? Okay, which is very important, right? And here, as the maximum and the minimum opening of machine platen, it is depending. Basically, it is important. Why? It is important. Why? For deciding the mold height, or you can say that stud height. Okay, you can shut it, but this data we can get from the machine catalog. Is it clear? Okay, I hope you understood. See, 30-ton injection molding machine data here. See, I'm showing the 30-ton injection molding machine data. Like tie bar distance for the 30-ton injection molding machine is 320 270, right? And the short volume 68 centimeter, not square. It will be cube. Is it clear? It is the short volume. Okay. Now tell me what is the density for the PP material. In previous lecture I have discussed about that, right? And for ABS also. What is the density for the PP?
0.9 grams per cc.
Yes. Okay. And ABS
1.02.
1.05, right? Yeah, 0.2 you can say that, right? So 1.05 gram per centimeter cube, right? So depending upon this density, if we multiply by the volume, so basically you will get the different short mass, okay, or the short capacity, right? So that's why this is the short volume. Is it clear? Minimum mold height, which is data you can say that minimum mold height and the maximum mold height. This data we will get from the machine catalog, which is the 150 mm for the 30-ton machine, and maximum mold height will be 550 mm. Is it clear? And injection pressure. This is the minimum, you can say that minimum or the maximum injection pressure, which is you can say that this is the range of the maximum, right? So this is the maximum injection pressure which can be provided by the injection machine. Is it clear? So basically it can be vary depending upon the component volume. For example, if your component volume, or if you have a component about 10 gram only, okay, so for the 10 gram component, there it is not required that it will be a 125 megapascal for filling this component, right? Maybe possible for the 10 gram component, we required only 15 to 20 megapascal, right? This is the maximum. Is it clear? Okay. Nozzle diameter. Okay. Achha, nozzle diameter means from where your material will be come from, right? Nozzle.
Injection
Injection
diameter.
nozzle. Yes, nozzle diameter. So it can be vary. it can be vary. Okay, so it can be 2.53, 3.54 for the big machine. For example, you are taking for example 300 ton machine. So for the 300 ton, 500 ton machine, it can be around 7 to 8 mm also, right? Okay. See, okay, acha, one more point I will add here. What is this? Ejection stroke. Okay, by which we can verify that what is the height of the component, right? So our component height should be less than this ejection stroke, right? But right or wrong, by which we can eject the
Yes.
component in a proper way, right? Okay, so this information is very important, right? This information is very important for start the design. But this is about the injection molding. But first of all, okay, understood or not? This is
Yes.
about the injection molding machine
Yes.
required data, right? Okay, now here,
Yes.
but one
Sir,
minute.
this meeting is recording.
Yes, 1 minute. Tell me check. Yes, of course, it is recording.
Okay.
Don't worry. I will provide you today link. Don't worry. Okay. Okay.
Sure, sir.
So when we start the design of injection mold, any type of injection mold, right? For any type of specific component, so basically we have to ask to the customer few questions, right, regarding that. Right? Before that, if we before without information, we cannot design any type of mold, right? So we should have knowledge about the components, right or wrong, or the component or the required data, you can say that, from the customer hand, right? Is it clear? Okay, so what is the important points? Okay, for example, you are designing any type of component, any specific type of component, so from the customer hand you should have knowledge about that points. Okay, so you must ask. Is it clear? If you, for example, if you start the design without information, what will happen there? Tell me. You have to take revision again, or the customer will fail your design, and you have to take the revision again. You have to prepare the complete mold again. Is it clear? Okay, so if you start the design without detail, okay, so your mold design will be failed by the customer. Is it clear? So again you have to design the design A, design B, design C, like this. Okay, is it clear? So this is the points here. See here. So design the for the design engineer, right? This is the questions and which you have to ask to the from the customer. Is it clear? First of all, what is the component? Okay, component, for example, if customer is providing you a component, is it in 2D or is in 3D? For example, if customer provide 2D data, what is the meaning of that? If customer provide 2D data, it means you have to prepare the 3D of this 2D, right? Understood or not?
Yes, sir. Got it.
Yeah. And for example, if customer provide you a 3D data, so there is no requirement for that, right? If customer provide 2D data, that you have to create the 3D data, and you have to prepare a 2D drawing again. Okay, 2D drawing again means you have to mention all the dimension, right? And again you have to send to the customer for the verification that our component design is you can say that for the verification purpose, right? Okay, that all the dimension is correct or not, or you can say that critical dimension of the component is correct or not. Is it clear? Okay, so first of all, 2D or the 3D data. If customer providing you 2D, if customer providing 3D data, it means it can be XT, STEP, IGS format, or any type of CAD format, right? So basically, if they are providing 3D data, it means it is the ready component, right? So you can start the design of the mold. Is it clear? Okay. Okay. Then again, how much number of cavities customer need? Okay. So basically you have to ask to the customer. Now, if I am talking about this second point, so second point is directly related to the this injection molding machine data also, right? How? For example, if customer required 10 number of cavities from the mold, okay, but one component mass is about 15 gram, 15 gram, and the machine capacity is only 100 gram. So can we prepare the 10 cavity of 15 gram 10 components? Each component mass is 15 gram. So can we prepare in this capacity 10 cavity?
Not
Not possible, right? So basically it is related with this data, right? Is it clear? Maximum we can create how much component we can create in 100 gram capacity. One component mass is 15 gram. How
so
much?
9. Sorry,
Huh.
6.
6, right? 6 we can provide. We cannot create the 6. I think fifth, 1 unit 50 and 4, which is the 6. So 6 will be 90 gram, right?
Yeah.
And if I'm talking about the feed system between them, then maybe we have to take the minimum 15% factor of safety for that, right? For the volume of air, right? So I think maximum I can design 4 cavity, sorry 6 cavity, about 60 gram, right? And feed system around 15 gram, so it will be around 85 gram, right? Right? Understood?
Yes.
Okay. Now see here, component material and its shrinkage value. Okay, we have to verify from the customer that what is the component or what is the material you will use, right? Okay, PP, PC, ABS, PA, or है ना, and the shrinkage value from the customer, and that what shrinkage value we can take from that, है ना, what shrinkage value we can take. Okay, for example, if customer says that sir we will use the PC material, है ना, we will use the PC material, but instead of the PC material during the production customer use PP material. अच्छा, what happened there, tell me? PC viscosity and the PP viscosity. For example, if the PP viscosity, for example, I'm taking the unit. If the PP viscosity is 5, then PC viscosity is 10. It is the twice. So what will happen there? Tell me. If customer says we will use PC material, but instead of the PC material, customer use PP material. So what will happen there? Tell me. It has lower viscosity. PP has lower viscosity. PPC has higher viscosity. So what will happen there? Because of the PP material,
Your raw material will consume.
no, it will create flashes. Okay, depending upon that PC material, we have to use the, or we will design the mold depending upon that PC material, right? Because customer says that we will use PC polycarbonate material. Okay, so it has a twice density of the PP. Understood? Flashes. It is like it is type of molding defect. So that's why we have to confirm from the customer end that what material we will use for the production of that component. Is it clear? So this is very important.
Okay.
है ना? Now if I'm talking about the PVC, which is the higher viscous material, more than others, which is the higher viscous material. Is it clear? So every material has has a few properties, right? So we have to confirm from the customer. Is it clear? Okay. है ना, shrinkage value as I told you. So all materials shrink during the cooling, and all the material has different shrinkage value. Is it clear? है ना? Now method of degating, automatic or manual. Okay, what is the meaning of that? Method of degating means separation of feed system from the component. What customer need? If they need a manual, it means it will be lower cost. If they need automatic, it means we have to implement a mechanism into the mold. It means it will be higher in cost. Is it clear? Okay, for example, this is the manual degating. This is the manual degating. Okay, now see, this is the automatic degating. It means For this we have to use a insert into the core part. See here, we have to use the insert into the core part. See here. Manufacturing will be complex, right or wrong? Understood? Okay, so we should ask about these points. Is it clear? Now again, one more point which is about available injection molding machine. That what injection molding machine has available to the customer. Now for example, customer has 30-ton machine, like 50-ton machine, like 80-ton machine, like 100-ton machine. So we should have knowledge about that. That we can in which machine we can prepare our component. Is it clear?
Yes, sir.
Okay, understood. Okay, so here see available injection molding machine, which is depending upon the short capacity also, and about the injection pressure. Okay, so depending upon the molding machine, short injection pressure will be different. Okay, for example, 30-ton injection molding machine has a different injection pressure range, है ना, and 50-ton injection molding machine has a different injection pressure range. Okay, okay, okay. Is it clear? Hot runner use, yes or no? This is the optional. Okay, this is the optional question. You can say that hot runner use, yes or no. Just customer have to tick yes or no. Why? Because of the hot runner is the different. You can say that this is the complete different apparatus. You can say that like this. Okay, so this is because of this mold cost will be increased. Is it clear? Acha, what is the hot runner? I think you have an idea about that.
Separate unit of heating the raw material.
And what is the benefit of this?
So it always keeps the stable
No,
flow.
it will be basically because of the hot runner, mold will produce only the component, not the feed system or the wastage material, right? That's why. Into the hot runner, material will be in melted condition. That's why. So it will produce only the component, right? So decision of the hot runner or the cold runner, it is depending upon the customer, right? And cold runner mold, as I told you, it will be less cost, and hot runner mold will be the high cost. Is it clear? Acha, one more point, which is the last point, which is the required production rate of the component. Acha, what is the importance of this point? For example, in a precision,
Here, what is the advantage of hot runner then?
hot runner basically, hot runner is used for basically, for example, you have a 10 gram component. Like for example, one component has a mass 10 gram. Is it clear? Is it clear?
Okay.
Okay. So
Yes.
basically, you are, for example, you are preparing in one mold like 4 component, right? And machine capacity has only 50 gram. 50 gram, for example, just okay. So basically, it will not produce a feed system. In cold runner system, what happened there? It will produce feed system also, like sprue, runner, sub runner, right? It will produce this also, right? So basically in hot runner system or in hot runner mold, it will produce only the component. So there is no wastage of the material.
Okay, no child parts, huh?
Yeah, no, they are not the child part. Feed system, what is the meaning of feed system? Feed
Oh,
system means
it's
like this.
so no runners, no runner, no gate system.
Yes, no runner and no gate system, you can say that, right? Like
Okay,
this.
okay.
So this, the feed system will not produce into the hot runner.
Okay, understood.
Okay, this is the benefit of that, right? Okay, last one point. What is the required production rate of the component? Okay, acha, how much production is required for the component from the mold? Okay, acha, what is the meaning of that? How much short? How much short customer need? For example, if customer need 5k shots. Yeah, for example, customer need only 100 shots. How much? Only 100 shot, and for the single cavity mold. Okay, or customer need only 100 component. Okay, so what material we can use? Tell me. And there is no precision. There is no precision of the component. So what material we can use for the core and cavity?
Aluminum.
Yeah, we can use aluminum. Absolutely. Right? But if the customer need thousand customer need thousand shot one 10,000 shots, okay, in a precise dimension. For example, customer need plus minus 0.1 tolerance in a dimension, and then what material we have to use?
Hardened
Hardened
materials.
materials like P20 material. Okay. Okay, so required production rate is very important. Required production rate is very important. Is it clear? So depending upon the production, how much production customer need, depending upon that we have to use the hardened material. है ना? Hardened material. For example, like aluminum, if we are used for the core and cavity, and what is the time required? For example, what is the tell me what is the VMC charges per hour? Around
300.
the 300 is the very cheap, right? I think or 500 per hour, right? Okay. So for machining into the aluminum, it need only 1 hour, for example. Okay. For MS, I'm creating same cavity, so it will take 3 hours, for example, and for the P20, it will take around 8 hours. Okay. So multiply by 500 for all. Only 500 rupees for the aluminum manufacturing cost, right? And if I'm talking about this 3 hour, it will be the 1500. And what is the cost for this? Around 4000 rupees for the P20. Right or wrong? Okay. And depending upon the
Yes.
critical geometry or the critical feature, if we are using ADM machining also, but depending upon that, cost will be high. Cost will be again high,
Yes.
right? So that's why required production rate is very important for choosing the core and cavity, material, right? So we can choose the core and cavity material depending upon the production rate, okay? Or we can suggest to the customer also. Is it clear? Okay, so these all
Yes.
points are very important, right? So as a designer, we should ask to the customer. Is it clear? Okay, this all information is very important for start the design. Okay, without this information, I'm suggesting you. You can say that I'm suggesting you that you should not start the design of mold. Is it clear? Is it clear?
Yes, sir.
Understood?
Yes.
Okay. So as I told you about the injection molding machine, so how to select the injection molding machine? Okay. How to select the injection molding machine? For example, customer has a 30 ton, 50 ton or the 80 ton machine. Okay. So we have to take the calculation. Okay. We have to done the calculation for that.